When evaluating an expression, we want to present everything in its simplest form. For radicals, this means evaluating what we can and leaving the rest inside the radical. In order to accomplish this, we need to understand factoring and use inverse operations. So let's get started. Before we get into simplifying radicals, let's make sure that we understand their structure. The radical is the symbol at the beginning that looks like a check mark. Inside of that is what we call the radicand. Radicands can be individual terms or entire expressions. The superscript in front is called the index. If there is no index written, we assume that it is a 2. We call this a square root. Radicals are the inverses of powers with the same index. The index of a power is indicated by the value of the exponent. Multipliers in front of a radical are called coefficients, just like they are when placed in front of a variable. Now that we have the structure, let's talk about what simplifying a radical actually means. Because radicals and powers are inverses, they undo each other. So if we have a base to the second power and take the second or square root, we will be left with the base. Because radicals are the inverse of powers, they must also have a foundation in repeated multiplication. The trick to simplifying radicals is finding factors of the radicand that are powers with the same index as the radical. This is achieved by a process called factoring. Remember that factors are numbers that multiply together to make a product. So when we factor a number, we break it back down into those values. We can also think of factors as numbers that will divide evenly into a value or be the result of such a division. If I were factoring the number 24, I would ask what numbers multiply to get 24. One answer would be 3 and 8. We could also say that 24 divided by 3 is 8. So 3 and 8 are factors of 24. But whenever we're simplifying radicals, we don't want just any factors. We want factors that can be written as a number to the same index as our radical. Essentially, if the index of the radical is n, we want to find x and y so that x to the n power times y equals the radicand of our radical. One way to quickly find the right factors is to use the table function on your calculator. You can set up the formula y equals the radicand divided by x to the correct index, start your table at 2, then look for the last row where x and y are integers before the y values are less than 1. Y and x to the n will both be factors. If y equals 1, then the radicand was a perfect square. So, if I'm taking the square root of 24, I'm looking for an index of 2. My table equation will be y equals 24 divided by x squared. When x equals 2, y equals 6. This means 2 squared and 6 are both factors. So 24 equals 2 squared times 6. Now we will use our inverse operations. Because the square root of x and x squared are inverses, they will cancel each other out, leaving the base. So similarly, the square root of 2 squared will equal 2. This 2 becomes a coefficient. 6 cannot be written as the second power of a whole number, so it will stay inside the radical. If there are variables in the radicand, you can simply divide their power by the radical's index. The quotient will become the exponent of the variable outside the radical, and the remainder will become the exponent of the variable inside the radical. So given the square root of x to the 5th, divide 5 by 2, this will result in 2 remainder 1. So the square root of x to the 5th is equal to x squared times the square root of x to the 1st. Let's practice these skills together. We are going to evaluate the third root of 128x to the 6th. We will start by factoring 128. If we make our table using the equation y equals 128 divided by x to the 3rd, we will see that the last pair of integers before the y value is less than 1 was x equals 4 and y equals 2. This means that 128 is equal to 4 to the 3rd times 2. Now, that means that 4 to the 3rd can be simplified to just 4, and brought out of the radical as a coefficient, while 2 has to stay inside the radical because it does not have the exponent of 3 to cancel with the radical's index of 3. Next, we will take care of the variable. 6 divided by 3 is 2, so the variable completely simplifies, giving us 4x squared times the third root of 2. Simplifying radicals will not only help us to evaluate or simplify expressions, it will also help us later on when we're solving equations. On top of that, the practice of simplifying radicals will help us to develop deeper number sense skills. In this video, we talked about how to factor a number and simplify a radical.